Okay, let's solve some inequality word problems. So I know word problems can be a little bit intimidating for some of us, but if we just focus on, identifying keywords and trying to keep a consistent system for solving these, you know, it should be pretty straightforward. I've also included, a little cheat sheet with some words to look out for that tell you what inequality we're working with. I also want to think about using let statements. So statements where we say, let x equal whatever we're solving for. Okay, so let x equal whatever we are solving for. Okay, so in this first problem, a Verizon phone plan costs $45, right? So we know that's going to come into play. The plan includes unlimited texting and calling, but charges $0.85 or 85 cents for each gigabyte of data. So 0.85 for each. Okay, when we see something like for each, that means times. So 0.85 times each gigabyte. What is the maximum amount of gigs you can afford if your budget is $60? So what is the unit we're solving for here? We're looking for the maximum amount of gigs. So I know that X is going to be, however many gigs of data. So our number of gigabytes of data. Okay, our budget is $60. So our budget is $60. I see this word maximum. So that means our budget is $60. So whatever we're spending should be less than or equal to 60. Okay, now let's think about what we're spending. The plan starts at 45 and we're charging 0.85 for each gig. So plus 0.85 times each gigabyte. From there, we're just going to go ahead, we're going to solve for x. Like any old algebra problem. So let's subtract our 45 from both sides. So we have what, 0.85x less than or equal to 60 minus 45, 15. Let's divide by 0.85. Now, I don't want you guys to be intimidated by a decimal, right? This is just 0.85 times x. We would cancel it out like we would cancel out any other number times x. We would divide. And when we divide, we get x is less than or equal to, I believe, 17.65. Okay, now units matter here, so let's specify. So 17.65 gigabytes of data. That's how much we can afford. Pretty hefty data plan if you ask me. Okay, let's look at another one. So we have Kara. She's going to the bakery. She only wants to spend between 40 and $60. She already spent $25 on a chocolate cake. So she already spent that much. How many $2.50 cookies can she buy? So how many? That's how much we're solving for. So we know that X is going to be however many cookies we can buy. Now, this word between is pretty important. Okay, it doesn't show up on our little cheat sheet here, but think about it in terms of inequality statements. Okay, when we do or statements, x is less than or equal to 7 or x is greater than or equal to 20. Right? Those are statements where when we graph them on the number line, our solution value is not in between the two endpoints. Whereas if we had something like, x is greater than or equal to 7 and x is less than or equal to 20, that's something we can rewrite with x between those two numbers. And we know that because if we were to graph it on a number line, the solution set is the numbers that lie in between 7 and 20. So when you see between, that's an indication that you're dealing with an and statement. Okay, you're going to have x in between two values. Okay, now think about, is it going to be less than or equal to or just less than? Now, since she can spend $40 or $60 exactly, it's going to be less than or equal to. So we know that she could spend as little as $40 or as much as $60. Okay, to set up the middle, we're going to think about her budget. So she's already spent $25. And in addition to that, she's spending $2.50 for each cookie. Okay, so there's our inequality. Now, when we have something like this, an and statement, we're going to go ahead and, we're going to split it up into two statements. So I'm going to have my 40 over here. And I'm just going to write 2.5x. I hope that's okay. And I'll put my other side over here. Now, the nice thing is, the steps to solve them are the exact same. So, if you're okay with solving it all at once, that's what I'm going to do. So let's subtract 25 from both sides. All sides, I should say. So we have, let's see, 15 less than or equal to 2.5x on one side, and 2.5x less than or equal to 60 minus 25, 35. All right, let's get the x by itself. Let's divide by 2.5. So let's see, 15 divided by 2.5, that is 6, less than or equal to x. And we have x less than or equal to 14. Okay, and we're going to go ahead and put those back into one statement. So x is in between 6 and 14. Okay, now what are our units? Units are cookies. So Kara, she can buy anywhere from 6 to 14 cookies, plus a chocolate cake. That's not bad.